Good morning. This morning we're going to be talking about the BOS butterfly valve line, and without further ado, we'll begin. Okay, the topics for today, we're going to do hands-on for both the BOS CL and the BOS US. If you look at our product line, the BOS CL, the BOS US, and the AWA butterfly valve, all our resilient seated butterfly valves, you'll notice the relative sales dollars of the BOS CL is quite low versus the BOS US. And likewise, the AWA valve, which is, certainly our highest selling product, and also the relative cost. The BOS CL is a commodity product, so it's very low cost. The BOS US has some specifiable features and certainly is a more industrial product and more robust product, and that certainly is a little more money. And again, the AWA butterfly valve in comparison is certainly a little more money yet, having a full, being rated to a full AWWAC 504 spec. These valves all can be used for on-off or modulating service. Again, we try to push people, you can see the cycle testing and that type of thing, that the BOS US is certainly a better product than the BOS CL as far as modulating service. And we'll talk about some other specifics on how the BOS US has some better features than the BOS CL. Again, the cycle duty that we do rate our valve, even our on-center valve, our BOS CL to 5,000 cycles. And you compare that to, again, the BOS US, we rate to 10,000 cycles, similar to the AWA valve. And the AWA valve is a 10,000 cycle duty rated valve. And certainly they can be, these valves can operate more cycles than that, but that would be, our proof of design testing is done at that. And, that would be basically a number that we actually publish to the field. Again, pressure rating, I'll notice the pressure rating of these valves. The on-center valve is the lowest pressure rated valve, 175 PSI, and versus the BOS US is a 250 PSI valve, as well as the AWA valve. We'll talk a little bit about specifics as we go.
On the table, I have cutaways of the BOS CL, the centerline disc on the left, and the BOS US, which is the uninterrupted seat on the right. And so these two products are identified by the type of disc. So the BOS CL has an on-center disc. So what does on-center disc mean? On-center disc means the shaft actually intersects or goes through the seating surface of the disc. So as you can see the hole for the shaft up on the top there, it would interrupt the seating surface of the disc, or it's on center. This valve is completely symmetrical. There's no upstream or downstream side. Pressure comes from either side of the disc. It's not going to matter. The valve itself is fewer parts, fewer machining, so it is a very low-cost construction. And one of the big advantages of this type of design is if you look at the profile of this disc, or how much room this disc actually takes up in the pipeline, it would be much less than the other disc we're going to talk about in a minute, which is the offset disc or the uninterrupted seat. So this valve will give you a higher CV or a higher flow rate, or it will take less energy costs to pump a liquid through the valve. So that is probably the biggest advantage, the cost, and the low head loss or the higher flow rate of the on-center disc. So the disadvantage of this type of valve is this is a high thrust or high torque valve. It takes a lot of operating force to actuate this valve. And part of the reason for that is this disc comes into the seat at, I'll call the 3 o'clock position here, or the 9 o'clock position there. It tends to push the seat outward. There's a lot of interference designed into this seat, especially up at the top. So as you're getting forces pushing out at 3 o'clock and 9 o'clock, you have a round hole inside the rubber seat, which the disc now is trying to make oblong. And so the way to counteract that is you have a lot of interference of the rubber. That interference of the rubber, that equates to the higher operating forces. The higher operating forces are going to require larger actuation. And more importantly, the more force you have on the rubber, it's going to give you lower cycle life. The other thing to note on this style of valve is because the disc is symmetrical and the shaft will interrupt the seating surface, you cannot isolate the shaft seal, which is provided between the seat and the shaft, from pressure in the pipeline. No matter how that valve is installed, with pressure coming from the right side or pressure coming from the left side, that shaft is always going to be exposed, or that shaft seal is always going to be exposed to the operating pressure. So that cannot be isolated. So let's talk a little bit about the offset disc. So we call it the BOS US, and the US stands for uninterrupted seat. So we have a full 360 degrees of seating surface on this disc. And we call it offset because unlike the CL or the center line, the shaft is offset from the seating surface of the disc. So what's the advantage of having that? And I guess I should mention, this is the same type of design that we use in the high-performance butterfly valves and also the AWA butterfly valves. I'd commonly refer to this valve as a poor man's high-performance butterfly valve. So the advantages of having the offset disc, the primary advantages are, one, the seating force. So as that disc comes into the seat, you have a uniform force 360 degrees around that disc. And so it has lower operating force than an on-center disc. The other advantage is the shaft seal can be isolated from line pressure in the closed position. So in the closed position, if your pressure was against the flat side of the disc, the shaft seal would not be exposed to any pressure. This valve is commonly used on vacuum applications. Think of vacuum applications as negative gauge pressure. And in that situation, if you put the vacuum on the flat side of the disc in the closed position, you do not, you isolate the shaft seal so you don't have to worry about losing the vacuum through that shaft seal. The disadvantages are pretty much the inverse of what the advantage is for the BOS CL. This is a higher cost valve. There's more parts, there's more machining. And then also, because the disc takes up more area in that pipeline, when product's flowing through the pipeline, there is more energy loss, or there's less flow rate. It takes more energy to produce the same amount of flow rate, however you want to look at that. And so from an energy standpoint, this valve would consume more energy for a liquid pump system for sure. All right, let's take a more detailed look at that BOS CL valve. So the BOS CL valve is a buyout product for Zurich. It is not our design. We actually have this manufactured for us offshore. It is another company's design, and it is private labeled and sold as a Zurich product. And you might ask, why would we do that? Well, a couple reasons. One is installed base. Zurich's been making a resilient seated centerline butterfly valve for a number of years, and we have a number of specifications out there. The Figure 660 and the BGS are previous versions. In a few minutes, I'll take a quick look so you're familiar with what those valves are in case they come up with specifications and what the differences are between our current product offering. We still have specifications out there written around the Zurich centerline resilient seated butterfly valve, and we still have the capability to supply a product to those specifications. It's important to note, even though this is not a core product, $1 of BOS CL versus $5 of BOS US versus $45 of AWA butterfly valves, there's still opportunity out there. Several years ago, we sold a $7 million order to an Aramco project, which was for a centerline butterfly valve. So there's still opportunities out there. You just need to understand where we can participate in those opportunities. So if you take a look at the BOS CL design, it is an iron body, and this body is only available in lugged. It is not available in wafer. It has a one-piece shaft. The shaft is a 400 series stainless steel. There are 3 disc options. The disc you're looking at right now is the nylon-coated iron disc. We also offer a bronze disc and a stainless steel disc. It has an elastomer seat, and that elastomer seat is bonded to a non-metallic backing ring. Because both of those are the same color, they're both black, it's going to be hard to differentiate between the two. The seat provides the flange seals. You have molded in rings on the face of that rubber seat, which will mate up against the mating pipe flange and provide the pipe seal. This seat is non-replaceable, so there's basically no recommended spare parts for this valve. When this valve is assembled, the OD of the seat is slightly larger than the ID of the body, and so it is a pressure fit. It is basically pushed into the body, the disc is put inside the body, and then the shaft is put through the disc. That's one of the reasons we're showing you a display valve cutaway, is this valve is not designed to be taken apart. One thing that's a little unique about this valve compared to other competitors is Zurich does offer 3 bearings. We'll have a bearing up at the top, which will take side loads from any actuator forces. We'll have a thinner bearing on top of the disc and on the bottom of the disc, and that's one of the reasons we can get a 5,000 cycle life out of this valve. A lot of our competitors will be somewhere in the neighborhood of 1,000 or 1,200 if they actually publish the cycle life for their valve. Another thing you'll notice on the top, or call out on the top, is we have this washer up here, which is called a retainer plate. Inside that washer, we have 2 holes drilled, and there are 2 screws which actually will attach the retainer plate to the iron body. And so that retainer plate helps provide what's called blowout-proof protection. So what's blowout-proof protection? Well, if the shaft to disc connection would ever be compromised, or if the shaft itself would break due to the high forces, something stuck in the pipeline, and the user would want to inspect the valve to see what was the problem. If there'd ever be a situation where they would have pressure in the pipeline and they would take the actuator off, we do not want the shaft to launch like a projectile. And so to do that, we have to design in blow-up-proof protection. And the way they do that is you have this retainer plate, which is attached to the body. Here's mechanically by screws. And underneath that retainer plate, inside the shaft, there is a small groove machined, and there's a snap ring. That snap ring goes into the groove, and the OD of the snap ring is greater than the ID of the retainer plate. So even if you lose your connection between the disc and the shaft, or if that shaft is actually compromised, breaks inside the body, it's not going to launch that shaft through that valve body. Okay, as you mentioned, the BOS CL does not have any recommended spare parts. If the seat seal or shaft seal would fail, the entire valve needs to be replaced. If recommended spare parts are required as a part of the bid, which is what happened in that Aramco project, we quoted a replacement valve assembly as the recommended spare parts. Okay, let's take a look at some of the previous versions of Zurich centerline discs so you understand the differences that they come up in specs. The oldest version I'm aware of for a non-center disc is what was called the Figure 660. Now this product is pretty unique. It's one of the very few products Zurich's manufactured that has a split body. So there's 2 body halves here, held in by 2 cap screws. I've removed the cap screws already so I can show you how easy it is to take this valve apart. Take the bottom body half off, you pull the cartridge out of the upper body half. And that was the design of this valve. It was a cartridge design. You had a resilient seat, a metal backup ring, you had a bottom shaft pushed into the disc, a top shaft pushed into the disc, and this was one assembly. So even though it was replaceable, this was an expensive way to replace it because in most cases the elastomer would wear out and you'd have to replace the whole disc shaft cartridge assembly. There are no parts available for this style of valve. The one thing the Figure 660 offered that the BOS CL does not offer, besides the replaceable parts, is this valve is fully rated for dead-end service. You can see the machining inside the body compared to the geometry of the rubber boot. The OD of the rubber is going to be larger than the ID of the body. So if a mating pipe flange would bolt up against this valve, it would hold that cartridge in place and this valve would be rated for dead-end service. And I probably should just define what dead-end service is. Wayne's going to cover that in a little more detail, but dead-end service is very common in HVAC systems. where you're going to do projects in phases, or it's where you're going to have an additional system added on later. And what that means is if you bolt that valve at the end of a pipeline with nothing downstream, that valve is going to be able to maintain shutoff. The figure 660 and the valve I'm going to talk about in a minute, the BGS, both are rated for dead-end service. The BOS CL is not rated for dead-end service. And so I should bring that back real quick because I should have mentioned that previously. The OD of the seat that is bonded to the backup ring is about the same dimension as the ID of the body. So if this is put into a pipeline with a mating flange and there's pressure put on the seat with nothing downstream to retain it, you could move that seat enough to create a leak path. And so we do not rate this valve for dead-end service. Or it is only rated for dead-end service if you have a downstream flange or donut to keep that seat in place. The more current version of the on-center disc valve is what was called the general service valve, or the BGS. And so this BGS valve utilized what's called a floppy boot liner. And so the floppy boot liner was molded with a ring down the middle and with dovetails on the outside, which would mate up into machined areas inside the body. So it was very easy to repair this valve. There was no solid connection between the disc and the shaft. There's just a square shaft with a broached square inside the disc that would go inside. In the bottom shaft, it actually just right inside a circle, and it could rotate inside there. So to take it apart, you basically pull the two shafts out, pull the disc out, you take this rubber boot liner out, and you could replace it. This valve was also rated for dead-end service because the OD of the rubber seat is it's greater than the ID of the body. And so once that is held in place by at least one flange, it's not going to move, and you're going to be able to maintain that shutoff. So if you see a specification for a BGS or even a figure 660, the replacement would be the BOS CL. And I think the caveat there is you'd have to double check to see if dead-end service is part of that specification or part of that requirement. But that would be the only option we'd have for the on-center disc. Okay, so let's take a look at the BOS US in more detail. So this also is a buyout product for Zurich. Zurich does not manufacture this valve. The big difference between the BOS US and the BOS CL is the BOS US is designed to Zurich specifications. So this is our design. This is manufactured exclusively for us. So as I take a look at the BOS US design, I'm going to focus on the 2 through 20 inch. The 24-inch and larger is a completely different design. This valve also has a one-piece ductile iron body. It is either available in wafer, which is shown here, or is available in lugged. It has a one-piece shaft. It has that offset disc. And again, I've got a smaller disc than obviously the valve size here. But the offset disc provides that 360 degrees uninterrupted seating. This is the biggest feature of this valve. Again, I call it the poor man high performance butterfly valve, and this is a very specifiable feature. The seat of this valve provides the sealing with the mating pipe flange. So there are protrusions molded into the seat, which are going to seal with the mating pipe flange. The seat itself is bonded to the body. This is a non-replaceable seat. There are some recommended spare parts to this valve, which I'll talk about, but the seat itself is not replaceable. If the seat gets damaged, you need to replace the entire valve body. This valve is rated for dead-end service, and it's rated for dead-end service, one, because the seat is bonded to the body, and also because the OD of the seat is much bigger than the ID of the body, so that seat is fully encapsulated or retained when you have a mating pipe flange pushing against it. So this is bidirectional, rated for dead-end service. Another feature of this valve is we have large bronze bearings, which are located at the top of the valve by the actuator mounting. Again, these bearings are designed to take any side loads, which are provided by the actuator. It has large bronze bearings above the disc and a large bronze bearing below the disc. This valve also provides blowout-proof protection. It does it similar to how the BOS CL, but a little bit different design. There's a washer in here, similar to the BOS CL, but instead of using screws to attach that washer to the body, we have a snap ring. That snap ring will go into the groove of the body, and it will hold that washer in place. Now, very fine detail, but underneath that retainer plate or that washer, there is another snap ring that is machined, that goes into a machine groove inside the shaft. And again, the OD of the snap ring below that retainer plate is bigger than the ID of that retainer plate, are called washer in our drawings. So if the disc to shaft connection becomes compromised, or if the shaft itself breaks, there's no way you're going to launch that shaft outside the valve body. The recommended spare parts for the BOS US are the upper bearing and the upper seal. That's it. If they need a replacement or recommended spare part for the seat, it would be the complete valve itself, as this valve is not designed to be taken apart and reassembled. Again, the biggest specifiable feature on this valve is going to be the 360-degree uninterrupted seal. So let's take a look at the previous version of the BOS US. And that valve was called the figure 632, or it was called the BRS. And that's basically the same valve. The only reason we had a name change was due to a change in our business systems. So very similar in construction between the old figure 632 BRS and the BOS US. It has an offset disc. It has an elastomer seat, but this valve was designed to be replaceable. There was a groove machined in the body. There's a groove machined in the backup ring for the elastomer seat, and a snap ring would fit in between there. And as you push that seat and snap ring into the body, that snap ring would lock into place inside that groove in the valve body. The BRS, the figure 632, had one unique feature that we did not carry forward with the BOS US. We decided from a standpoint of cost and how much it was used in the field, it wasn't worth bringing forward. But if you notice the seat on the old figure 632 or the BRS, it did have a seating surface on both sides of the seat. And so in theory, or in actuality, if one side of the rubber would get damaged, but the disc was still good, you could turn the disc 180 degrees and you'd have a rubber seating surface on the other side of the valve. One of the things you have to be aware of with the old BRS or the figure 632 is the way that the valve was designed, there was not a lot of, the OD of the rubber boot was not very large. And so it was very critical when it was mounted up to pipe flanges that everything was aligned perfectly. And with some flanges like Weldnick flanges, it was likely that the flange would not seal against the rubber part of the boot. And so what the Zurich would do in those cases would be provide flange seals. Flange seals were very large diameter, thin washers that had elastomers adhered to the metal component. And what it would basically do is you put it between the pipe flange and the valve, and would just increase the amount of rubber surface to make sure you had a good connection between the pipe flange and the valve body.
So the BOS valve, it does go, the new BOS valves that we have today are to a standard. They're to MSS SP67. And like all the acronyms we use, I'll try to describe it. Manufactured, MSS is a Manufactured Standard Society of Valves and Fittings Industry, and it's standard practice 67. And what that does is it basically gives us the background for any of these rubber seated butterflies. Basically design, they have to be designed with a pressure rating to this standard, the wall thickness, the stem retention, and the flanging. Likewise, the dimensions of the valve, the face-to-face dimensions are to the standard. Previously, our figure 660 our mainly I'll say our BRS, I believe, in figure 632 were not to this standard. They were actually previous to before the standard was even in place. So we do have some unique installed base with our BRS in figure 632 that we can do some things with the BOS US to do some replacements. Likewise, the MSS SB 67 gives us a testing requirements, and the valves are shell tested to 1.5 times the rated pressure. And likewise, they are seat tested at equal to or greater than the rated pressure, and Zurich does that at 1.1 times the rated pressure. And then the shutoff has to be drip tight. The flange sealing, on the BOS US, the 20-inch and smaller, and the BOS CL 24-inch and smaller, they have an integral seal to provide the flange seal. No gaskets are required, and again, being that they're up to date and current, again, somewhat unlike the figure 632 and BRS, these no flange sealing other than the integral seat itself is required. The larger BOS US, the 24 through 36, as well as the BOS CL 26 and larger, is basically a flange design, and it requires a flange gasket. Again, previously our BRS in figure 632, when you use weld neck flanges, we often would need an additional flange seal, like that thin stainless seat with, or say stainless material with rubber on it to provide a flange seal. Again, that's no longer required with the current designs. As far as dead end service, the BOS US is fully rated either direction for dead end service. We do show the BOS CL, we noted in our bulletin as dead end service rated, but that would require a downstream flange. So if you're looking at noticing this picture here, that would be a picture of the BOS US without a downstream flange. If you use a BOS CL, a downstream flange has to be installed to provide it dead end service and to take the pipeline down, downstream of the valve. Both products, the BOS US as well as the BOS CL, in these sizes are NSF rated, meaning they're certified for drinking water applications. Now that doesn't mean they're food grade rated. So food grade rating is a different rating, and so again, sometimes you'll be asked if to do a food grade rating, and we do not meet that. So there's certainly a lot of other competitors that do, but we're only certified for drinking water applications, which again, most of the applications for water applications they might ask for that, and we certainly have that full rating, NSF. The larger sizes, the BOS US, they're rated to 175 PSI and fully bidirectional, and these were unchanged from the previous BRS. So this product is just been remarketed as the BOS US, and we have a great installed base for these products. And again, this has an unusual or a different face-to-face than probably most other competitor products that are out there. Again, this was made previous to the MSS SP 67 standard. And so, again, there's certainly some installed base that we enjoy and can replace with our product that we still are making today. The thing about the BOS US, these larger, they do have replaceable seats. They are a repairable valve, unlike the smaller BOS US and BOS CL valves. The seat can be replaced. It's similar to our AWA valve in that it has a replaceable seat. It's basically attached to a metal ring and held in place by multiple fasteners. And likewise, it's easy enough to take apart this valve because it has tangential pins. It's basically, again, similar to an AWWA C504 design with a compression loaded pin, a tangential disc to shaft pin. So again, easy to take apart, a great strong disc to shaft connection, so a very reliable, long lasting valve. And that's why we have, like I said, many in service, and we can enjoy doing replacements for this product with the BOS US. The packing is an adjustable, replaceable, multiple D-ring packing. Again, this is, same type of packing that we use on our plug valves, our BHPs, certainly our AWA valves, in our control valves, our V-port valve valves, and RCVs. So again, this is a great sealing system. Again, definitely good because these are intended to be used for a long time, and certainly has a wear and replaceable packing system. In summary on the product, as far as specifiable features, the BOS US, again, the uninterrupted seat design, which is definitely an unusual compared to most competitive products. It certainly is a different design than most of all of our resilient seated competitors. So it's definitely specifiable. It has a spline disc to shaft connection, and it's 250 PSI rated. And again, the larger 24 through 36 inch are 175 PSI rated. It is an NSF 61 approved valve for drinking water service and has a 10,000 cycle rating that we publish, and fully dead end service, bidirectional dead end service rated. Versus the BOS CL, the on-center design, that is a pin disc to shaft connection. It's 175 PSI rated on the 2 through 12 inch and 150 PSI rated on the 14 inch through 48 inch design. It also is NSF rated, and we do rate it for 5,000 cycles, which is unlike a lot of our competitors won't provide a rating like that, again, in those type of things that are special to our product that allow it to be a good longevity, our on-center valve to be a great product, and certainly gives us some good longevity.